This is Mr. T with another tutorial in our trigonometry series. We're going to now move away from right triangles and talk about oblique triangles. Oblique means not a right triangle. And we're going to learn about two different formulas or laws that we will be using for solving oblique triangles. We're going to start with the one that's called law of sines. And what the law of sines says is that for any triangle, the ratio of the sine of an angle over the length of its opposite side is equivalent or equal for every pair in the triangle. So I've shown a triangle here, and I labeled the angles with capital letters and the sides with lower letters. And remember, our normal scheme is to label the side opposite an angle with the lowercase of that letter. And I've shown our ratios. Now there's three ratios here. On any given problem we will use a pair of these depending on the given information. Also, something to be careful about in oblique triangle problems, angle C will not necessarily be the biggest angle, and side C is not a hypotenuse. It's not the longest side necessarily. And lastly, another warning is we cannot use the Pythagorean theorem for these problems because it's not a right triangle. That only applies when we have the right triangle. So let's look at a sample problem. So we're given this information, triangle ABC, and we're given this information. And I made a triangle here. Let's label our sides and angles. So C is an obtuse angle 103, so we'll put C here. So in this case it is the biggest angle, but as I said, for triangle problems that won't always be the case. Doesn't matter which one we call A or B, so let's call this B. It's 28 degrees, and side B is 26, and we want to solve the triangle. So we have to find angle A, side A, and side C. Now we can find angle A easily here because we know our angles have to add up to 180 degrees. So we have here 131 degrees. So if I subtract that from 180, we get 49 degrees for angle A, so that was easy. Now we have to pick and form a ratio here, and our ratio is the sine of an angle over its opposite side and the sine in another one. Well, let's add here, we can fill in 49 here. So for one of the ratios, we've got four numbers. If we use a pair of these, we've got four numbers, an A, two angles, and two sides. So kind of one of the tenets of algebra is if you have a single equation, you can only have one unknown. So to be able to use law of sines, we need to plug in three of these four numbers. So we're always going to need an angle and an opposite pair as part of our problem. So we can set up here sine of 28 over 26, and now we can use one of the pairs where we're missing a piece of information. So we can use here this, and I forgot to label that C, so we have sine of 103 over C. Now we have a proportion problem, so we cross multiply. And we're trying to solve for C, so this is multiplication, so we can divide both sides of the equation by sine of 28. And we can use our calculator here to calculate that. So we have 26 sine of 103. Now I earlier verified that my calculator was in degree mode. And we get 53.9, or let's just round that to the nearest whole number. So we have 54 here for side C. And we will have to set up a similar pair for, let's put this up here, we had 54. To do A, we can use again one of these pairs. It'll be more accurate if we take the given information that was exact as opposed to side C where we rounded. And now we need sine of angle A over side A, and we're going to cross multiply again, and then I'm going to have to divide by the sine of 28, so I get 26 times the sine of 49 divided by the sine of 28, and we can calculate again. Let's bring up that previous entry, and we can replace the 103 with 49. And we get 41.8, or we could round that to say, since I rounded the other one to a whole number, we will round that to 42. So we have side A being 42, and we've solved our problem because we found all our information. Law of sines will work for any problem where we know two angles and one side. In this case, we knew angle, angle, side. It could also work if it was angle, side, angle, because we can always find the third angle using this rule. So if we're given two angles, we'll know three angles, and as long as we're given one other side, we can solve it using law of sines. So let's look at situations where we're only given one angle. Those are referred to as side-side angle problems. So we have two sides that are a fixed length and a given angle. And we don't know the length of this side, so I drew it for an unknown length, and these angles are also unknown. They're not fixed. Now the issue with side-side angle is we have a lot of different situations that can happen. So if B is too short, we have a situation that's shown here, and you can see I cannot form an angle. I have a dangling side here. Now you have to pretend that, remember B was given as fixed. So one possibility we have is that we could have no solution. Now let's assume B was longer. Let's assume it was just long enough to reach down here. So if it was just long enough to reach here, this would form a right angle. If we go a little this way, it doesn't touch. If we go a little this way, it doesn't touch. So we have one solution. And on all these problems we're doing here, we have theta fixed is an acute angle. We'll look at it in a minute when it happens to be a obtuse angle. Now let's make B just a little longer yet. So now let's say it connected here. We could have a solution, but it could also swing if it was the same length and connect there. So we could have a triangle that's an acute solution and one that's obtuse. So with that same configuration, two sides and an angle, we could have two solutions. Again, one of them will be acute and one will be obtuse. And then finally, on this situation with acute angles, let's make B be really long. So we have one solution here, but when we swing this, it won't connect until over here outside the triangle. So this is no longer inside the triangle, so that's not a solution. So again, we have here only one solution if B is too long. Now to get each of these situations, the only thing that varied on these was how long side B was relative to side A. So now let's go back and look at what if our given angle was obtuse. So let's adjust our picture here. So let's swing that around. So now we have our given angle is obtuse. Now again, if B is too short, we still have the situation where we would have no solution. And then if we make B longer, the situation where it comes straight down, that doesn't work because that's outside the triangle. So we need something that's longer than side A, and that's going to give us one solution. And no matter how short or long we make it, we're still only going to get one solution. So just to sum up what we talked about here, if the given angle is acute, there's a possibility that we have no solution, one solution, or two solution, and that will depend on the relative lengths of these sides. And if the given angle is obtuse, there's a possibility of either no solution or one solution. Now if you look in a algebra book or a trig book, there are formulas that tell you, given the relative sides of B and A, using the given angle, how to determine the sides, but we're going to show how we can do this mathematically. The no solution case, you will end up getting an error when you try to do some of the math. I'll show that in a minute. And we'll talk about how we can determine whether there are one or two solutions. So let's go to our next slide. So again, only time we have the chance of two solutions is when our given angle is an acute angle. So I've drawn the two solution situation and the one solution situation. Remember, this is too long so that when we pivot this angle here, it goes outside. What I'm interested in here is looking at our two solutions. So this is our first solution, theta, and our second solution, theta prime. Let's look at the relationship between these two angles. Now in this case, this side, B here, is fixed. So these two sides are the same. So we have between our two solutions here, this is an isosceles triangle, and in an isosceles triangle, this angle will be equal to this angle. And our first solution and second solution are supplementary here. So our second solution, if it exists, will be 180 degrees minus our first solution. So again, this is our second solution angle, and this is our first. In this situation, if we use that same formula, remember this is an acute angle, so if we use that situation, this is going to be obtuse, but we have an obtuse angle here because this was given to acute, and we have two obtuse angles. So what will happen when we try to do this math for a situation where it's not possible to have two solutions, the sum of our angles will end up being greater than 180, which obviously is impossible for a triangle. So let's go through our process. So on these problems, let's sketch a picture, but we won't worry about it being exactly to scale. So we have A, which was given to be 50. Our opposite side was 2. Let's call this B. We have a given side B is 8, and this would be angle C and C, and we're supposed to solve this triangle. Now, if we drew the picture, we probably can tell that this side is so short that we're going to have a dangling side, so no solution. But let's see how it comes out in the math. So we have here our pair here, so we're going to use sine of 50 divided by 2, and we have here one other side, so we're going to use this pair. So sine of B over 8. we can multiply both sides by 8 so that we can get the sine of b by itself. Now in this situation our angle is unknown, so to find b we have to take the inverse sine of this calculation. And if we try that in our calculator here, we get sine inverse of 8 times the sine of 50 divided by 2. And we get a domain error because this is 4 times the sine of 50. This comes out to be bigger than 1. And remember, the domain of the inverse sine is between positive and negative 1. So we get no angle here. So therefore, again, we have no solution. So we ended up getting a domain error that led us to know that this problem has no solution. Okay, let's look at one that has one solution. So our triangle here, (50 degrees), this is 10, this is 8, so we can tell here that just from the picture that we're going to likely have a solution because this side's longer, so it will reach. Now the question is whether we have only one solution here, which I'm telling you it does, but we're going to see how that works, or whether this could pivot over and show up here and have a second solution. So the only law of sines ratio that we can set up at the beginning is angle A over side A, and now sine of B over side B. Again, we're going to multiply by 8. So we get the sine of b. Let me reverse these sides. 8 times the sine of 50 over 10. And we take our inverse of that ratio here. So if we can use our calculator here, we have the inverse sine of 8 times the sine of 50 divided by 10, and we get our acute solution, which is 37.8 degrees. Now we know we're going to get an acute solution because if you remember the lesson on inverse sine, the inverse sine function always returns angles between positive and negative 90 degrees. It always returns an acute angle. Let's go ahead. We're solving our first solution, so let's finish the first solution here. So we have 37.8 here. So now we can find angle C, which is going to be 180 minus 50 minus 37.8, which comes out to be 92.2 degrees. And then we can set up one more law of sines ratio. Sine of 92.2 over C equals, and let's use our original given information that wasn't rounded. Oops, that's 10, sorry. And we again cross multiply, and then we're going to divide by the sine of 50, so we get C equals 10 times the sine of 92.2 over the sine of 50. Again, I cross multiplied here, so I had C times sine of 50 equals 10 times that. I have to solve for C, so I divided by sine of 50, and I've already computed that, so let's save time. This video is going long, so let's get that, and we get approximately 13. So we have our first solution, which has B, this is C, and this is side C. Now we need to check whether there is a possible second solution. Now in our second solution, the given information is the same. So A prime is the same as A, because that was fixed. We couldn't change it. B is 8, and A is 10. Now we said from our picture that if a second solution exists, it will be supplementary to the first solution. So our second solution, if it exists, B prime, will be 180 minus 37.8, which comes out to be 142.2 degrees. So C prime, if it exists, the sum of the three angles have to add up to 180. So 180 minus A prime, which is 50, minus 142.2, and for C prime to work, it comes out to be negative 12.2 degrees. Or we can see here our A prime and B prime already add up to be more than 180 degrees. So our second solution is not valid. So we only have one solution, as I had indicated. So let's wrap up here and look at a situation where the second solution does work. So we have here our triangle. This is given 50 degrees. This is still 8. This time side A is 7. So again, we're going to start out the same way we did before. Sine of 50 over 7 equals sine of B over 8. Let's multiply by 8. So we get sine of B is going to be 8 times the sine of 50 over 7. We're going to take the inverse sine of that. And I've already computed this, so I'm saving time not punching in the calculator. You've watched me enter the calculator. We get here 61.1 degrees. So let's continue finding the first solution. So to find side C, angle C, is going to be 180 minus the A and minus B. And C comes out to be 68.9 degrees. And we set up to find side C, so the sine of 68.9 over side C, and sine of A over A, and when we solve that, we get, and again we've shown the solution, we get 8.5. So our first solution we have here. So let's check our second solution. Let's do that in red. So again, on our second solution, A prime is still 50, B prime is still 8, little a prime is 7. But what we said is if there's a second solution, we take the first angle we found, that's this angle here, and we find its alternate, which is supplementary to that angle. And we would have here 180 minus 61.1, which comes out to be 118 degrees, 118.9 degrees. Now we can see here, if we add 50 to that, we have 168.9. So our C prime is going to be a valid angle. And that comes out to be 11.1 degrees. So if you get to this point, then we have a valid second solution because we have three legitimate angles, 50, 118.9, and 11.1. So we have to find a alternate for side C because it's going to be a different length. So we can set up sine of 50 over 7 equals sine of 11.1 over little c. We cross multiply. divide by the sine of 50. And we use our calculator to compute this, and we get, for the second solution, C is, let's see here, I didn't compute that yet, so let's compute that. So 7 times the sine of 11.1 divided by sine of 50, and we get about 1.8. So we have our second solution here, B prime, C prime, and little c. So on these problems we have to list both solutions, or you're going to be, missing out on part of the problem. To help you remember this, if we be a little bit inappropriate here, as you can see, doing all this work is a bit of a pain, and we had here that this was an SSA problem. If we change the order of these, let's move this A over here, this is a angle side-side problem, and you can tell that this problem is a pain. So remember that ASS, or politically correct speaking, SSA problems are a pain, meaning you must check for two solutions. So let's just summarize real quick. This is our law of sines. You're going to want to memorize that. We can use law of sines for solving angle, angle, side, side angle. So anytime you have two angles, you can use law of sines. And if you're given two sides and an adjacent angle here, we can use law of sines. And we must remember on these problems to check for a second solution. And we showed that in the second solution, if it exists, we are going to, this first angle that we found in the math is going to be supplementary to that angle. And best of luck.